This video will talk about how to divide polynomials with a monomial divisor. I'm going to share to you right now the material for a practice exercise. In this given practice exercise, we are given with a monomial divisor. Let us check. Right? So all the divisors here are considered to be monomial. Now, you can still use here the long division if you want to, but of course, there is a very simple process when we're going to divide any monomial, any polynomial with a monomial divisor. It is actually patterned to the concept of fractions, such as, let us say, 2 plus 3 all over 2. This is actually taken from the sum of two different fractions, which is considered to be 2 over 2 and 3 halves. Again, this expression here just came from the combination of two fractions, 2 halves, or just simply equal to 1, and 3 halves. Since we have similar bases, we just operated the numerator and then copy the base. Again, copy the denominator rather. So that's why we have 2 plus 3 all over 2. We are going to use this concept when we are going to divide any polynomial with a monomial divisor. As for number 1, this symbol here can be represented by a division bar. And therefore, this expression will just be equivalent to a rational expression 4m squared plus 16m, sorry for that, 16m all over 4m. Okay, so again, this can be transformed into a division bar, and we will have here a rational expression, again, 4m squared plus 16m all over 4m. And then we are going to use the same process here, that instead of simplifying this, of course, we all know that this is actually just be equal to 5 halves. But we are not looking for the answer for this expression. We're just looking at the relationship between this expression to the previous expression here. So we can actually apply it here. So instead of having this into this as a whole numerator, we can break the numerator and then place the denominator to both sides. Again, let's use the separator plus, as we also used it in the previous videos, which are all concerned on multiplication of polynomials. And you have here 16m all over 4m. Okay. When you're going to share the denominator to both terms here, take note what is similar to what happened to the denominator 2 here. When you share the 2 to the numerator 2, making it 2 halves, that the same denominator will also be copied here for the second term. That's why we have 3 halves. The 2 here did not separate as 1 and 1. They still remain as denominator 2. So do not think like if you're going to distribute this or share this to both sides, and you might say, I'm going to use 2m, I'm going to use 2m, because I'm just splitting the rational expression into two different fractions. No, when we say same denominator, we just simply use 4m and 4m. And out from this, we just simply use here the simple division of monomial to monomial using the division law of exponents. So 4 divided by 4 is just 1. And we use the law of exponent 2 minus 1. 2 is this exponent of the numerator, and 1 is the exponent of the denominator. Please do not interchange the two values because there is no commutativity or commutative property for subtraction. This is for the first term. As for the second term, since we use again separator plus, and we have 16 divided by 4 is just 4, and then use the division law, you have 1 minus 1. And then next, 1 here as a numerical coefficient could be not be written anymore. So you have here m, 2 minus 1 is simply 1. And then we have 4 plus 4 m to the power of 0. 4 to the power of 0 is just equal to 1. So this expression will be equal to 1 times 4 will just be equal to 4. Or if you're going to go back here in this process, you can just simply cancel this out and cancel it out on on the other side. Therefore, the final answer here is an expression where the exponent 1 is just uh, not to be written anymore. And we have here plus 4, and then you have this is equal to 1. So this is actually the value or the resulting quotient when we are going to divide 4m squared plus 16m by a monomial divisor 4m. Okay. Again, since this is a division of polynomials, we use the division law of exponents. We need to subtract the exponents with the minuend as the exponent of the numerator, and the subtrahend would be the exponent of the denominator. Now, I want to know, sir, if my answer is correct or not. Okay. So if you would really want to know whether your answer is correct or not, by the way, this is optional. You may or may not do this, but if you really want to make sure that your answer is correct, you could always do this to check whether our answer is correct or not. This is also a pattern with the simple process of division. Let's say 4 divided by 2, the answer is 2. We all know that. How do we know that our quotient here is answer, even if its quotient is correct, even if it's very obvious? We can actually use the reverse operation of division, and we can just multiply the quotient to the divisor, and you have 2 times 2. It should result to the quotient. So 2 times 2 is equal to 4, and this is actually the way that we are sure that our quotient here is really correct. So again, how do we check it? We multiply the divisor, sorry for that, we are going to multiply the quotient to the divisor. I'm just using a shortcut here, and it should return to the value of the dividend. If it will not return to the value of the dividend, then you have two concerns there. Number one, your quotient might be incorrect, or number two, your checking is maybe incorrect. Okay, so it's up to you if you will still use this, but I am encouraging everyone to check. So let us try to know if our answer here, our quotient here, when multiplied to our divisor, will return to the dividend. Again, multiply this to the divisor. Will it return to the dividend? Let's find out. You have your divisor, because that's the monomial, you can use 4m times m plus 4 as the quotient. You can interchange the two because again, this is multiplication and multiplication is commutative. So when we multiply, we simply use the distributive property here and there, and then you will have 4 times 1 is 4, and then m, since this is multiplication, we are going to use the multiplication law of exponents, which is 1 plus 1. And the other side, use the operator plus. 4 times 4 is 16. We don't have other m, so that's m. Simplified, that's 4m squared plus 16m. As you can see, this value here is our original dividend. Therefore, the quotient, which is m plus 4, is actually correct for number 1. Again, this is optional, but I'm encouraging you to do this for the rest of the items. But our concern is, of course, finding the quotient. So let's continue with number 2. Number 2, you have 9x to the power of 4 minus 3x cubed plus you have here 15x squared can be rewritten as the irrational expression over negative 3x. Right? And then we use the same process we did earlier. So you have 9x to the power of 4 all over negative 3x. Regardless of whether this is the operation here is addition or subtraction, I'm always encouraging you to please use addition. Well, it doesn't. It will not matter later because if the answer will be negative, it will remain negative. If the answer is positive, it will remain positive, because as we have discussed in grouping symbols, when we have a plus sign before a grouping symbol, all the signs in the grouping symbols will retain as itself. So we have here, so since we use plus, this will be taken charge, the negative sign will be taken charge with the second term, negative 3x cubed. You write it properly, 3x cubed all over negative 3x. And again, use separator plus, and then you have here 15 x squared all over negative 3x. Now that we have split or shared, probably the better word, the denominator to all the terms in the numerator, we simply combine them, or I mean, simplify them separately, independently. 9 divided by negative 3 is negative 3, and then you have x4 minus 1. And then you have the next one, plus, you're using the operator addition here. You have negative 3 divided by negative 3 is positive 1. And then you have x 3 minus 1. And then finally, you have plus 15 divided by negative 3 is negative 5. And then you have x 2 minus 1 using the division law of exponents. And then simplify each term. So you have negative 3 x 3 minus 4 is 3, plus, you may not write 1 anymore here. So you have x 3 minus 2 is squared. And then you use here the breaking of grouping symbols that we have learned before. So positive times negative, you have negative 5x to the power of 2 minus 1, which is 1, or may not be written because it automatically means with exponent of 1. This is our quotient for number 2. Again, to make sure that our answer, our quotient is correct, you may multiply this with the divisor, and it should return to the dividend. If it will not return to the dividend, again, the two concerns there is number one, your quotient might be incorrect, or number two, your multiplication process in checking may also be incorrect. Okay, that's a good way to check both operations. And let's have number three. Number three here. So you have 25 x to the power of 5 minus 15 xy all over 5x. Same thing, share the denominator. So you have 25 x to the power of 5 all over 5x. And again, separator plus, if it's okay with you. Of course, I am just using the safest process, but if you can actually divide this automatically by your own method, your own choosing, well, it's just okay. And then you have 5x. And then you have here 25 divided by 5 is 5. X to the power of 5 minus 1. And then you have plus 5, 15 divided by negative 15 divided by 5 is negative 3. And x 1 minus 1. And then you live with y because y has no other partner. And then your final quotient must be 5. X to the power of 5 minus 1, which is 4. And then apply again here the breaking of the grouping symbols. So you will have here minus 3. 1 minus 1 is 0. So this is x to the power of 0, which is just equal to 1. Or if you want to, I'm still going to write it. And you have your y. So the simplified answer here is still 5x to the power of 4 minus 3. X to the power of 0 is just equal to 1. So 3 times 1 is just 3. And you have here y. This quotient may be verified when you're going to multiply this to the monomial divisor. And again, it should return to our original dividend for you to be sure that your quotient is correct. This is the process of dividing polynomials if your divisor is a monomial expression. Of course, there are other processes that may be useful here, such as the long division or other method that you are more comfortable with. Do not worry, as long as they follow the correct and proper mathematical operations, they will still be accepted as your as final answers. But this is what we did here. These are the simplest processes. So thank you for watching, and we are going to learn for the next video how to divide polynomials with a binomial divisor. So let's see in if what should be the process that should be used for those items. Thank you very much. See you.